Hello everybody and welcome to another video lesson. Today we're going over multiplying matrices. Our objective for today, we're going to be able to perform matrix operations, including multiplying matrices. So let's get right into it. A little review, we're going to look at adding matrices together and multiplying by a scalar. Okay, so if I have matrix A and matrix B right over here, okay, if I were to add A and B together, okay, well, that just looks like the first element in row 1, column 1 of A, and the first element of row 1, column 1 of B, okay, and that's going to be our A11 plus B11. And same thing, the second element in row 1, okay, or the row 1, column 2, okay, it's going to be here, and row 1, column 2 for B is going to be there, okay? So hopefully we've seen that before. And as far as multiplying by a scalar, if I were to say 3 by A, well, I can just say that each element in matrix A is going to be multiplied by 3, okay? So a little review there, but now if we're looking at multiplying matrices, okay, well, we haven't done that before, so let's take a look at what this looks like. Okay, if I have matrix A and matrix B here, okay, first thing we need to understand is a little bit about the dimensions of our matrices. Okay, so when I talk about dimensions of a matrix, we talk about row by column, okay, kind of like a rectangle, right? I've got base by height, right? So rows by columns for our matrices. So our rows is our rows, row, 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 all right? And then our columns here, 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 column, column, okay? So rows by columns. So matrix A is 2 by 3, right? 2 rows by 3 columns, okay? So when we multiply matrices, we actually have this requirement where we need to kind of list out the rows and columns for each of our matrices. So we need to look at the dimensions for each one side by side, and it does matter the order. So if I have A times B, I need to list out matrix A first times matrix B when I'm listing out my dimensions, okay? Because I have this requirement that says the number of columns in the first matrix needs to equal the number of rows in the second, okay? So these two numbers need to equal each other if I'm going to be able to multiply matrix A and matrix B, okay? So if that is true, then we can multiply them. Our output matrix, AB, is going to have the dimensions of my outer two dimensions here from A and B, okay? So matrix AB here is going to be a 2 by 2 matrix after I multiply these two together, okay? Okay, so let's take a look at our process here for doing that. If I have A times B, right, first thing I'm going to do, I'm going to have a look at, I know this is a 2 by 2, so my first element in row 1 is going to be row 1 of matrix A and column 1 of matrix B, okay? So we're looking at first. I'll go ahead and erase some of these. Gotta clean that up. Okay, so our process here, I've got the first element in row 1, okay, times the first element in column 1 of B. And so we have here, first element of row 1 times the first element in column 1. So I've got a product here. I've got 3 products that I'm adding together. Okay, because the second thing I'm going to do is say this second element in row 1, I'm going to multiply that with the second element in column 1. Okay, so second element in row 1, second element in column 1 of B. All right, and then we'll go third element, we'll just do a little jaggedy line here. Third element of row 1 is going to be multiplied by the third element in column 1 for our other matrix, okay? So I've got third element in row 1 times third element in column 1. And I'm just adding, okay, keep in mind I've got addition here in between, okay? So I'm adding these 3 products together. And then I move on to my row 1, column 2 here. Okay, so now I'm looking at, I'll go ahead and erase this again. Okay, again, looking at row 1, column 2, okay? row 1, column 2. So think about this matrix and what element you're looking at. Well, I'm looking here at row 1, column 2, right? This is column 2, and this is, or that's row 2, sorry, and this is column 1. Okay, so I'm looking at row 1, column 2, so I need to be analyzing row 1 and column 2 as far as two matrices that I'm multiplying together. Okay, so again, I've got first element in row 1 times the first element in column 2, here and here. And I've got the second element in row 1 times the second element in column 2. Third element in row 1 times the third element in column 2. And we're adding those products together. Okay, adding them up. All right, and come down here. Now I've got row 2, column 1. Okay, so now I'm going to move down here to row 2 for my first one, for my first matrix, row 2, column 1. Okay, so I've got the first element in row 2 times the first element in column 2. Okay, and this should be multiplication here. This should be multiplication, so don't get that confused. Okay, and same here. This should be multiplication over here. Okay, so I've got a product here, plus now I've got the second element in row 2, okay, multiplying that by the second element in column 1, right here. And then I'll take a look at the third element in row 2 and multiply that with the third element in column 1. Again, I'm looking at row 2, column 1 for my output matrix, okay? And then my last element here is going to be row 2, column 2. So I'm looking at row 2 again, but now column 2 for my matrix B. Okay, column 2. All right, so I've got the first element in row 1 times the first element in column 2, and I've got the second element in row 1, the second element in row 2 times the second element in column 2, and I've got the third element in row 2 times the third element in column 2. Okay, and again, I'm just adding those products together. Okay, so that might look kind of weird with a bunch of letters in here, so we'll take a look at a few examples here shortly. Okay, but before we do that, I just want to go over some quick properties of matrix multiplication, one of them being the associative property. Okay, and we're going to kind of prove this associative property, and then I'll give you some other properties that we'll work with. Okay, so our associative property, if I have matrix A, B, and C, again, A, B, and C are all matrices, okay, then AB times C and A times BC should be equal to each other. So let's take a look at that. So here, A is going to be in blue, B is in orange, and C is in red, okay? And I'm going to go ahead and multiply A times B first on the left-hand side here, and then we'll multiply B times C first on the right-hand side, okay? So AB, again, using the process we just did, is going to give us AE plus BG, AF plus BH, CE plus DG, and CF plus DH here. Okay, so this is AB right here. That's AB. Okay. And then I've got C again here in red. Okay. So now I'm going to multiply AB by C, and when we do that, we get this long thing right here. Go ahead and erase that. Okay, so I've got IAE plus IBG plus KAF plus KPH, and so on. Okay, I'm left with a 2 by 2 matrix here, is what I'm left with. All right. Okay, so over here, I'm going to pause there. Over here, I'm going to multiply B by C first, and when I do that, I get A stays the same, and I've got EI plus FK, EJ plus FL, JI plus HK, and GJ plus HL. Okay, a lot of letters in there. Then I can go ahead and multiply A and BC. So again, this is BC and this is A. So when I multiply those together, this is what I get. Okay, so all I need to do now is go through and check, are these the same? Okay, well here I have, let's say I've got IAE, well, that's the same as AEI. I've got IBG, that's the same as BGI. Okay, I've got KAF, that's the same as AFK, and I've got KBH, that's the same as BHK. Okay, looking over here, I've got ICE, I've got CEI, I've got IDG, that's DGI, I've got KEF. Let's see, this is an E, I believe. Yeah, this is an E. Sorry about that, handwriting's horrible. KEF, KEF. Oh, this is actually, let's see, this is, okay, I figured it out. The mistake was over here. Okay, so I had KCF, CFK, and then KDH and DH. Okay, writing on tablets is hard, and sometimes my C's look like E's, and it's horrible. Okay, so here I've got JAE and AEJ. Let's see, I've got JBG and another one, another mess up here. Let's see, I believe this should be a J right here. Let's see if I've got, yeah, this would be a J right here. It wouldn't make sense to have an I, so this is actually a J. Again, J's, I's, E's, and C's. It's a whole thing. Okay, so now I have LAF and AFL. I've got LBH and BHL. I've got in my second row, second column, JCE, CEJ. I've got JDG, DGJ, LCF, FCFL, and LDH, DHL. All right, we've made it through the proof. Very good. Okay, so we can see here that we do have the associative property of matrix multiplication that is true and valid. Okay, so a few other properties of matrix multiplication. Okay, we got the associative property that we just proved. We got the associative property of scalar multiples, and we've got left distributive property and right distributive property. Okay, so make sure you write these down, and make sure you also write down in this case that A, B, and C are all matrices. Matrices. Oh, is there an E in there? Or an I in there? I don't think so. Spelling is also not my strong suit. Okay, so A, B, and C are all matrices, and K is a scalar. Okay, K is a scalar for these. Okay, so write these down and make sure you write down these kind of stipulations as well. Okay, let's take a look next at our identity matrix. Okay, our identity matrix is for square matrices only, meaning I have the same number of rows as I do columns. Okay, same number of rows as I do columns. So here I have a 4 by 4. So that's what we mean here when I say I sub n is an n by n matrix. Okay, it means we have the same amount of rows as columns. All right, and why we call it the identity matrix is because I can multiply any matrix by the identity matrix, and we get the same matrix out. Okay, here I have A, and my output here is A after multiplying it by our identity matrix. Okay, so that's what we call the identity matrix. In the same way, if I were to multiply 3 by 1, well, that just equals 3. Okay, so if I have matrix A by times our identity matrix, well, that just equals A again. Okay, and where this comes in handy is with our systems of equations again that we saw last lesson. If we're given a system like this, we can actually write this as a matrix equation. Okay, so here I have my coefficients matrix, and then I've got my variable matrices, or my variable matrix here, and my constants matrix here. Okay, and what we did when we put this into an augmented matrix was we basically turned this whole coefficients matrix into this identity matrix, right? Which looks like our reduced row echelon form. Okay, so let's go ahead and put all of this together with a few examples. Okay, let's take a look at finding AB and BA if possible. Okay, and it says if possible because it's very important, if possible, because again we need to check our dimensions. Okay, so I've got A, which is a 2 by 3, and B, which is a 3 by 2. So our 3's are equal to each other, and I know that AB is going to be a 2 by 2 matrix. Okay? So again, our process, I'm taking a look at the first row and the first column, okay? It's going to be row 1, row 2, column 1, column 2. So here, first row, first column, I'm looking at the first row and the first column of A and B, okay? Okay, find my product of my corresponding elements, and then I add those products up. Okay, moving on to row 1, column 2. Okay, so that's going to be this right here, right? Row 1, column 2. Okay, that's row 1 of my first matrix and column 2 of my second. Okay, again, I'm finding the product of my corresponding elements, and I'm adding those products together. Okay. Then when I move down to my second row, okay, for AB, I've got row 2, column 1. So now I'm looking at row 2 of A, column 1 of B, and I'm multiplying, okay, multiplying the corresponding elements together and adding those up, okay? And then same thing with row 2, column 2. And then I just go through my operations here. So I have -4 plus this goes to 0 plus 3 times 9 is 27. Okay, and then I've got 0 and 0 here plus 3 times 3 is 9, so that's just 9. And then row 2, column 1 is going to be 5 times 2, that's 10. Okay, plus -7 times -1 is 7, and 1 times 9 is 9. Okay, and then I've got a 0 plus 1 times 3 is just 3. Okay, so that's how we go ahead and reduce this down and simplify it, and this is what AB is going to look like. Okay. Okay, so again with BA, just because AB works out does not mean that BA is going to work out. Okay, in this case it does because I have 2 is equal to 2. All right, and I know that BA is going to end up being a 3 by 3 matrix. All right, and what that looks like, a little bit more involved here. Okay, but it's the exact same process, except now okay, I've got row 1, row 2, row 3, column 1, column 2, column 3. Okay. Now, first I want to look at B. Okay, so I'm looking at the rows of B, and I'm analyzing that with the columns of A. Okay, so row 1, column 1 for my BA, now I've got 2 times -2, and I'm adding that with 0 times 5. Okay, and then when I moving on to row 1, column 2. Okay, again, that's row 1 of my first one, column 2 of my second matrix. Okay, so I'll have 2 times 0 plus 0 times -7. That's what we have here. All right, and then I move on again to my row 1, column 3. So I've got row 1, column 3. So I've got 2 times 3 plus 0 times 1, okay, which is what we have here. I'm just adding those products together, all right? And then as I move down, okay, row 2, column 1. So row 2 of my first matrix, which is B, column 1 here, okay? Again, I'll have row 2, column 2, which is next. So then I've got -1 times 0, and I've got 0 times -7. Okay, and then moving on, row 2, column 3. So I'll have row 2 of B, column 3 of A. So I'll have -1 times 3, and I'm going to add that with 0 times 1. And I do the same thing for my final row of BA. And when I do that and start reducing it down, it's going to look like this. And BA is going to be this 3 by 3 matrix that you see here. I'll get this 2 out of the way. Okay, so make sure you're taking notes on that whole process and making sure we understand that efficiently, okay? This is going to come in handy. All right, now let's take out an example. Here, A, B, and maybe even BA are not going to work. Why is that? Because when I look at the dimensions, okay, I've got A is a 2 by 3 and B is a 2 by 3, and those are not equal to each other, right? My 3 is not equal to 2. Okay, so I would say that AB does not exist. Okay, and if I have BA, again, B is a 2 by 3, A is a 2 by 3, so my 3 does not equal to 2, so BA does not exist as well. All right, writing a system of equations as a matrix equation, which we saw in our concept slides, AX is equal to B. Then use Gauss-Jordan elimination in the augmented matrix AB to solve the system. Okay, so first thing we're going to look at a matrix equation, AXB. Okay, so what that looks like, I've got three matrices here. Okay, I've got my coefficients matrix, which we looked at. I've got my variables, and I've got my constants. Okay. Okay, so this is what my matrix equation would look like. Okay, A is my coefficients, X is my variables here, and then B here is my constants. Okay, AX equals B is what we mean when we say a matrix equation like this. Okay, so now in order to solve, I'm going to go ahead and put this into an augmented matrix. Okay, so I'm just taking my coefficient matrix and I'm putting that on the left-hand side, so that's separating with the dotted line, and I've got my constants on the right-hand side. Okay, and then we're just going to go through our operations to get the left-hand side to look like reduced row echelon form, which looks like our identity matrix on just the left-hand side of our augmented matrix. Okay, so I'm going to say 4R1 plus R2 is going to be the new R2. It's going to get rid of this 4 right here and make that a 0. And I've got negative 2R1 plus R3. That's going to be the new R3. And that's going to get rid of this 2 here, going to make that a 0. And I'm going to say R2 plus R3 is going to be the new R3. Now when I do that, notice something. I've got a 4, 8 here. And I really want this 4 to be, I want that to be a 1, right? This 4 to be a 1. So, lucky for me, both of these are multiples of 4, or divisible by 4. So I'm just going to go ahead and multiply this by 1/4 before I put it into my new matrix, okay? So now instead of putting in 4, 8, I've got 1, 2, okay? And I just went ahead and multiplied that by 1/4 before redrawing my matrix. Okay, now I got to work on my row 2 here because I got a -7 and a -4. So I'm going to go ahead and say row 2 plus 4 row 3 is going to be the new row 2. And again, I get 2 elements that are, because I'm getting rid of this -4 here is what I'm trying to do. Okay, and I'm successful in that, it becomes a 0. But now these 2 elements that I'm left with are both divisible by 7. Okay, and I want this to be a positive 1 for it to be reduced row echelon form. So I'm going to multiply by -1/7, and that's going to give me a 1 and a -4 in my matrix when I redraw it. Okay, so now I got to work on these 3 and this 2. So first let's tackle the 3. So I've got row 1 minus 3 row 3. That's going to be the new row 1. That takes care of the 3. Now I want to work on this 2. So I'm going to say row 1 minus 2 row 2 equals the new row 1. And when I do that, I see we do get rid of the 2. So now, awesome, the left-hand side looks like our identity matrix. It looks like it is in reduced row echelon form, and we can write our final solution like so. So that is all for this lesson, a bit of a longer one, but good luck on your practice.